Okay, picking up right where we left off. So we did the left. Now we will do the right. And so the limit as x approaches 3 from the right of 4x over 3 minus x. Again, we're going to substitute. And again, I get that 12 over 0. But again, it's about what's really happening in that 0, because it isn't really 0. It's a number really, really close to 0, but what we need to know is it really, really close to 0 and positive or really, really close to 0 and negative. So I'll do the same thing again and put that little plus, and we're going to remember that x approaches 3 means close to 3. But greater than. So what I've got here is 3 minus greater than 3. Or thinking 3 minus 3.00001. That is positive. That doesn't look like a 3. And so I'm going to put a little positive sign there. That's where that little positive sign comes from. Except I'm wrong there. So pretend none of that happened. 3 minus greater than 3 is negative. I love whiteout. One of the best inventions ever. So there we get that little negative sign. And again, that 0 negative, that's just my personal thing, means negative, less than 0. I'm going to run out of room there, so let's try again. That 0 negative means less than 0. And things that are less than 0 are negative. And so then I look at what I have. I have positive 12 over negative. That this is now positive over negative, which then makes my answer negative infinity. The infinity part comes from the non-zero over 0. That's why we've got to see the non-zero over 0. Then once you have the non-zero over 0, you have to decide whether things are going to be positive infinity or negative infinity. And now because we have the left and right limits, we can now say what the two-sided limit is. So the limit as x goes to 3, the two-sided limit of 4x over x minus 3 does not exist. And then all of this should check. You can take your calculator and graph your function, and I'll show you what I get when I graph it here momentarily. So can we see that? Yeah, you can see that fairly. Yeah, there, that's pretty good. Now notice when I graph it, the entire numerator is in parentheses, entire denominator, and I'm just going to graph it on the standard window, zoom 6. And there's my graph, and we see an asymptote, and we said, and you can still, can you still see it? No, you can't quite see it up there. Just off the top of the screen, we said from the left. Okay, good example. We said from the left, you can't see it on the top of the screen. We said from the left that the answer was positive infinity. And notice what we got here from the left, it's negative infinity. So something is going wrong, and this is a good reason to check things. I didn't do this on purpose to make it go wrong. I just made a mistake. But our work said on the left it was going to be positive infinity, and when I look at this graph on the left, it's going to negative infinity. So either my work is wrong, or what's wrong is I typed in the function wrong. I typed in x minus 3 instead of 3 minus x. So let's go fix that. 3 minus x, and graph that. And there's my graph now, and notice as we go from the left, the graph, as we approach 3, we're going nearly straight up. We hit the asymptote because the function was undefined at 3. And then we don't see much of the curve, but we can imagine that as we're going to the right over here, we can imagine that it is going to negative infinity. Now, if you want to do a better window to see what's going on, let's graph it instead of from negative 10 to 10 on the y-axis. Let's try it from maybe negative 20 to 20 and count that off by 2's. And then when we graph it, we'll see a little bit better picture. And so from the left, we see it go to positive infinity. From the right, we see it going to negative infinity, and then the two-sided does not exist. So you can check these things by looking at graphs. And you can do that with any limit. We haven't spent a lot of time checking our graph, checking our limits with graphs, but you can check any limit by looking at a graph. Or you could use the table function in your calculator. If you like the table function, you could use the table function in your calculator. And actually, let's go ahead and look at the table function while I have it out there. So I'm going to hit second and table. And now we need to get near 3. So I'm just going to, I could set up a better table, but I'll just get close to 3. And actually, I do need to set up a better table. So let's do second and table set. And let's start counting at maybe 2.8, and let's count by 0.01. So I'm going to start at 2.8 and then start counting up by 0.01 each time. And then let's see what we get. Second and table. And so notice as we start getting closer and closer to 3, my y values are getting bigger and bigger and bigger. We can see them getting bigger. Then when I hit 3, I get an error, undefined. Let's zoom in a little bit. So we can see as we get closer and closer to 3, the numbers are getting bigger and bigger and bigger, so positive infinity. We hit 3, an error, because it's undefined there. And then if we keep going, we see now that they're negative, that on the other side we're approaching negative infinity. So you can also check these things by looking at a table. You can either look at tables or look at graphs, whichever you want. But if you've got a few extra minutes, check things. Checking is good. Okay, let's zoom back out. So there's our first problem, a limit, what was called an infinite limit, because we got an answer that was infinity. Or in this case, infinity, negative infinity does not exist. Okay, moving on to the next problem. Determine the limits. So, limit as x approaches 1 of x over x squared minus 1. Start by substitution. So I'm going to have 1 squared minus 1, that's going to be 1 over 0, which immediately tells me it's infinity, negative infinity, or does not exist. And because it's a two-sided, now important, the does not exist, that is only possible in a two-sided. If it's a left or right limit, the answer is either going to be infinity or negative infinity, as the case may be. So again, since it's two-sided, because two-sided, must do left, right. And we will do it the exact same way we did the other one. Let's start on the left. So the limit as x approaches 1 from the left of x over x squared minus 1. Substitute. And we're approaching from the left. So I'll put the little left in there, and we're still going to get 1 over 0. And again, the important thing here is that that's non-zero over 0. This is what we do when substitution gives us non-zero over zero. Then reason out what's going on here, that this is less than 1 squared minus 1, which would still be less than 1 minus 1, which would be negative. And if you can't reason it out, pick an actual number and do the arithmetic. 0.9, which is not particularly close to 1, but we'll take 0.9, which is less than 1. 0.9 squared is 0.81. 0.81 minus 1 is negative 0.19. It's negative. So I've got positive 1 over something close to 0 but negative, positive over negative. And so this is negative infinity. The non-zero over 0 is what tells you it has to be infinity or negative infinity. Then figuring out what's really happening in that number that's close to 0, whether it's close to 0 and positive or close to 0 and negative, along with what's going on in the numerator. If the numerator was negative, then I have a negative over a negative, that'd be positive. But then I look at both of them and see what's going on. We're going to end this recording and pick up on the next one.